So in section 1.2, we started talking about the idea of limits. In particular, we looked at the limits on the ends of the graph. We call them end behavior. What we're going to do in this section is look at the limits on the interior of the graph at specific values. So instead of at the extremities, at locations of specific interest in the in-between parts. So the first thing is to talk about what a limit actually is. A limit is, conceptually anyway, a y value that a function approaches and it may or may not equal. It could equal it, but it doesn't have to for it to still be a limit. Now you'll notice some familiar notation, right? We saw this limit f of x stuff in the last section. We saw the x arrow in the last section. The part that's new is what comes after the x arrow. The 3 plus, the 3 minus, and the 3. The first one, 3 plus, actually talks about taking the limit as you approach the number 3 from the right. We have an example right after this slide, so all will make a little more sense when we get there. So this is the right-hand side of the graph. It's the right-hand side of my body, at least from your perspective. So we're coming at it from this direction, right? That's what the plus means. We're coming at it from the positive side. The 3 minus, the limit as x approaches the 3 negative, means we're coming at it from the negative side of the graph. So from the left-hand side, we're moving closer to whatever that value, in this case 3, is. 3 plus is coming from the positive side. 3 minus is coming from the negative side. I'm just using the number 3. It could be any number, okay? It could be 50. It could be 4.2. I don't know. And then if there's not a plus or a minus, it has to mean you come from both directions. So you come from here, I come from here, and we got to meet. So you can actually approach a value from the left and approach a value from the right and not approach the same value. If we were having a conversation, I said, I'll meet you at McDonald's, and I go to the McDonald's on Harrison and you go to the McDonald's on Kickapoo, we're both going to a McDonald's, but we're not going to end up there together because we're going to different places, right? So the limit can actually work from both ways but not match up. And that's actually the picture that we have on the next slide. This looks like y'all are done writing. Does your picture look something like this? Mine on my piece of paper actually doesn't look very smooth right here, but these are actually the open circle and that curve is supposed to touch. So if yours isn't looking quite connected, it should just make it connect like it's supposed to. We're looking at graphs, right? This is a graph. So what we're doing is actually graphical limits, right? Look at a graph, you're doing graphical limits. This is to graphically estimate the values indicated and answer the question. So there's actually 5 questions posed, 5 different limits we're going to answer. Notice the first 3 anyway are all hovering around this value of -1. See my -1s there? And over here on my graph, that's -1. Yeah, are you with me? Okay, so first you have to figure out where on the graph we're actually looking. So the reality is, on this graph, we're looking sort of nearby here. Because that's the area that's sort of close to the x value of -1. A little bit to the left, a little bit to the right, but we're near 1, -1. So let's actually take a look at the questions individually now. This one says positive. It means it's coming at the value of -1 from which side? The right, the positive side of the graph. So imagine, it doesn't matter where you start really, that you're on the graph, you're supposed to be moving towards the right-hand side, and once you get as close as you possibly can to the x value of -1, your question you're asking yourself is, what y value am I getting close to? What y value is it? It's 2. Right? At this open circle is approximately, so we're looking for approximately's, at -1, 2. We're getting really close to the y value of 2. So this limit is 2. Now the next question says that we're approaching the value from the negative, right? There's a little negative there. So what does that mean? From the left, you bet. So again, we're on our curve. We're not on the number line axis itself. We're on the curve, which is awfully flat for that portion of it. And we're getting really, really, really close to that open, or that solid filled in dot there. Okay, what is the y value if I can get as close as I want to that solid black dot? I'm at a y value of 1. And this is exactly the problem I was describing before. From one direction, we're getting close to 2. From the other direction, we're getting close to 1. And they don't meet. Right? When that happens, we say that the limit does not exist. D&E is an abbreviation for that if you would like it. It doesn't exist. And it doesn't exist because they don't match. If they matched, if they both came to the value of 1, then the limit would exist, and it would be 1. But they don't match. In particular, what's happening on our graph, I got so much garbage on my graph, let me clear it off, is that because my graph has a jump in it, they can't match. One side is one direction, the other side is the other direction. All right, the other two questions go back to section 1.2. They ask us to go to negative infinity and positive infinity. Well, just by show of you waving your arms in the air, where is x equals negative infinity going to take us? That way, right? Yeah, it's going to go that way. So we're going along our curve this direction. What is the y value as I move in that direction that I get close to? I'm actually on it the whole way. It's 1. Right? It's at 1. This one just, it's straight. It's a horizontal line. So it doesn't actually have any sort of, it just is 1. The other one, though, says x approaches positive infinity, which means I'm going to go to the right. Yeah? So if I'm going to x equals positive infinity, I'm going like this. Can you tell what it's doing? Or any guesses as to what you might think it is doing? It's going up real slow, but it's going up. So you're right, it's infinity. Let me tell you what it would look like if it was leveling out, because you might look at that and say, well, how am I supposed to know? Because it's doing it so slowly. If it were leveling out, the question itself would have drawn in for you a horizontal asymptote, and it would have looked something like this. They'd have a dotted line there. So if there were a dotted line there, you'd look at what that dotted line was representing in terms of how high it was from the x-axis, and that would actually be your limit. But that's not on this graph. So what we have to assume is that it's going up forever, and it's infinity. All right, let me let you write down. Actually, you know what? Because I've got a question after it. We'll stop right there because the next two pieces go together. So 1.3 is not assigned, 1.2 is. So make sure when you come next time, you come with questions for 1.2 or have completed 1.2, and we will go from there.